Hi, in this video we'll be talking about the problem KTHVAL from CodeNite challenge. So in this problem you're given an array A and there are m ranges that you need to add into a set. So for each of the range you will be given an L and R value, and all the elements in the range will be added to the multiset S once. Okay, and finally the elements in the set S is kept in a sorted place, and there are q queries. For each of the query you are given k, and you need to find the kth element in this sorted arrangement that you have made from all the ranges that you have picked up. Okay, so the constraints for this was around 10 to the power 5, yeah, and the ki can be up to 10 to the power 18, and in case there are not sufficient elements in the set, you return -1. You report -1, you print -1. Yep. So that's the whole problem. So let's get into the solution idea for this. Okay, so over here we have a particular array, right? We have a particular array, and with that array we need to take ranges out of it and insert into some set. So if we do that naively, that would be order n into m, right? For every m you could have potentially added all of the elements in the array. So let's try to take an array. Okay, let's have some values in this. Let's fill up with some values. Let's say there are just 3, 2, 4, 9, something like this. Okay, there are only 4 values for now. Okay, let's also keep them as 1 and 8. Okay, there are some values in the array, and now on this array there will be some queries given. So suppose you need to add once, say this range, and say this range. Okay, so suppose you need to add these two ranges into a set and get the set out. Okay, so you need to add this range into the set. So obviously the total number of elements in the set can be pretty large. Like you can add the whole array m number of times. So if you just keep the whole set, that would not be possible. So let's try to create a different thing. Let's try to create the set in such a way that we keep the number and its frequency in the set. Okay, so for every number in this, like let's say this 9, how many times this 9 appeared in this set. Okay, so that's what we will maintain. So there are many ways to actually calculate this, that how many times a particular element in this array would be present in the set. So one way you can do this is using something called partial sums, that given these many ranges, how many times will this 9 get added? How do you find that? Using partial sums. So let's look into how we do that generally. So if you have this, let's suppose you add to this range, this particular range over here. Okay, when you add this range, what we do is that we do a +1 over here, and after the end of this we do a -1. Okay, similarly for this particular range, the upper one, we do a +1 over here. Sorry, this would be +1, and -1 after the end. So -1 would go something outside, so we don't want to keep that. Okay, so we just do all these for all the queries that are given to us, and then at the end build a prefix sum of this. Okay, so the prefix sum would be 1, then prefix sum of this would be 2, 2, 2. These are zeros. Okay, and then the prefix sum up to this point would be 1, then 0, right? So if you see that these values 1, 2, 2, 1, 0 are actually the frequencies of the elements, that how many times will that get added to this set. Okay, and you can do this in order n plus m, because for every query you just need to add at 2 positions. Like you do a +1 at this position and a -1 at this position for every query, and then after all the queries done, you need to just build the prefix sum. So this will give you the contribution of every element in the array. So you get a number from a frequency for every number. Okay, so this is the first part, that given all the queries, you now know how many times a particular element in the array will come in the answer. Okay, so let's make it a smaller instance now. So let's say 3 comes twice, 4 comes thrice, okay, and 2 comes once. Okay, let's say these are the frequency comma number pairs. Okay, so now we will sort them. So sorting inside it would be same as doing it this way, right? Because every frequency of these two will come together. All the 4s, there are 3 4s, right? But all of them will come together, so we can keep them together as well in this case. So this would be something like this, right? Now given this, after you have sorted it, like you found this using the partial sum technique, and then you sorted it up using the values. Now there are some queries, right? Now you need to find the kth element in this. So there is 1 2 2 3s and 3 4s. So in actual this would be 2 3 3 4 4 4. Okay, this is the actual S or set that is there. Now you need to find the kth element. So what we do is that in order to do this fast, what we can do is, rather than going in and searching the kth element in this linearly, what we can do is we can create a prefix sum of the second values. So the second values are 1 2 3, right? So we build a prefix sum, that is 1 3 6. Now what does this prefix sum mean? That every element now says that how many elements are less than equal to 3, how many elements are less than equal to 2, how many elements are less than equal to 4. That is what is being saved in this prefix sum, right? And now if you want to do a search for the kth element, what you can do is you can use a binary search on this. How? So let's say we want to find the first element. Okay, let's say we want to find the first element. How do you find the first element of this particular array? So what is the element? Okay, so this is up to 3, right? There are 3 elements less than equal to this. So first element will come out over here, second element should come to this, third element should come to this, fourth element should come to this, in this way, right? So for every element, so for every k, you need to find the position of the first element that is greater than equal to that particular k, right? Find pause such that this prefix that you built, prefix of pause, is greater than equal to a. Find the first such pause, right? And this you can find easily using a binary search. To be precise, you can find this out using lower bounds as well. Okay, so you can use inbuilt searches, you can implement binary search on your own, but once you build this prefix sum, finding the kth element is just like doing a binary search on the first position that is greater than equal to k, because before that there was less than equal to k elements, but now there are more than k elements. So that is the class where this kth element lies. So if you search for, let's say we try to search for, let's say 5. Okay, let's say we try to search for 5. So in that case, the first position that is greater than equal to 5 is this 6, right? So for that 6, we find out which is the element over here, this 4, and this is your answer. So answer is 4 in that case. For the fifth element is 4, which you can see is correct, right? Similarly, you can check for other elements as well. So for this problem, you had to first of all find the number of times every element gets into this. So you could have used segment tree and all, but those are really overkill for this. This partial sum technique comes really handy when the queries are all together and you don't need to report the array in between. So you can use this simple, easy linear time partial sum technique to get the number and the frequencies, and then once you have that, you can just build the array in this compressed form, that how many times a particular element happens, and after you have sorted it, you just build a prefix sum on the second values, that is the number of times they come, and now it will save the number of elements that is less than equal to particular value. So this will store the number of elements less than equal to 3, this will store number of elements less than equal to 4, and now in this array you just need to find the first pause that is greater than equal to k, and that is really a binary search problem. Okay, so with binary search you can find for every query in order log n. Okay, so this will take you in total order n log n. Okay, order n log n for the sorting over here plus q log n. Okay, so this will be the final complexity for this problem. So that was the whole idea for this problem. Thank you.